Okay, so now let's look at a different type of problem, trying to find a confidence interval for a mean, a sample mean. So a researcher is trying to understand how stressed out full-time college students are who also work part-time. That would be your population, okay? But the researcher cannot survey every single student who fulfills those criteria. So he or she takes a sample of 74 full-time college students who also work part-time and ask them to rate their stress level during finals week on a scale of 1 to 10, with 1 being the lowest and 10 being the highest. Okay, so the researcher gets a sample mean of those 74 students of 6.35, okay, and a standard deviation of 1.96. Now, based on that criteria, you should be able to calculate confidence intervals at both the 95 and 99% levels. Okay, so let's go ahead and walk through that problem now. So we still have our key information over in the upper left-hand corner. Again, a sample size of 74, a mean of 6.35, and a standard deviation of 1.96. Now we have to calculate our standard error before going over to the confidence interval. So our standard error formula for a mean is you take your standard deviation and divide by the square root of your sample size, or your n. Which means we take 1.96, our standard deviation, and divide it by the square root of 74, which ends up being 1.96 divided by 8.60. And that gives us a final standard error of 0.23. Now we can take that and put it into a confidence interval formula. Now I asked you to calculate a 95% and 99% confidence interval. So let's look at the 95% confidence interval first. Again, we take our sample mean and we can add and subtract the product of your z-score and your standard error. So our sample mean again is 6.35. And you're going to add and subtract the product of your selected z-score of 1.96. That's what corresponds with a 95% confidence interval, times your standard error of 0.23. So you get 6.35 plus or minus that product, which is 0.45. So you take your sample mean of 6.35 and subtract 0.45, and you get 5.90. If you take your sample mean and add 0.45, you get a sample mean of 6.80. That is your confidence interval. So then what we can say is, based on our sample size of 74 students, full-time students who also work part-time, we can say with 95% confidence that if we surveyed every single student in the population who is a full-time student and works part-time, that their stress level would be somewhere between 5.90 and 6.80 on that scale of 1 to 10. Now let's calculate a confidence interval for 99%. All that means is we change the selected z-score. Okay, now you can see we've switched over to a 99% confidence interval. Alright, everything else stays the same. We still have, obviously, the same sample size of 74, a mean of 6.35, again, that's your observed mean, and a standard deviation of 1.96. So our standard error does not change at all. All we're going to change is, if you look at the writing in green, since we're looking for a 99% confidence interval, we still take our sample mean plus or minus the product of a z-score the z-score and our standard error. Okay? But since we're looking for a 99% confidence interval, the selected z-score changes from 1.96 to 2.58, where the arrow is. Okay? And you multiply that times, again, your standard error of 0.23. So that product is 0.59. And again, you just take that sample mean, the observed sample mean of 6.35, and subtract 0.59. That gives you 5.76. If you add 6.35 and 0.59 together, that gives you 6.94. That range there from 5.76 to 6.94 is your 99% confidence interval. Okay, so then we can say that based on our sample of 74 students who are full-time students and work part-time and have a stress level of 6.35, we can say if we surveyed all the students in that population who are full-time students and work part-time, that their stress level would be somewhere between 5.76 and 6.94. We can say that we're 99% confident their mean or their average stress level would fall somewhere within that range. Another way of explaining it is to say if we did this survey 100 times with 74 students in that population, in 99 of those cases, we could expect to get a sample mean between 5.76 and 6.94. Either one of those ways that you want to explain it is fine. Okay, but that's the process for getting a 99 and 95% confidence interval for a mean.